Welcome in physics class. Dear students, today we are going to start unit number 4, turning effect of forces. Dear students, after studying this unit, you will be able to define like and unlike parallel forces, state head-to-tail rule of vector addition of force and vectors. Describe how forces is resolved into perpendicular components. Explain the turning effect of force by relating it to everyday life. State the principle of moment. Define center of mass and center of gravity of body. Define couple as a pair of forces tending to produce rotation. Prove that the couple has the same moment about all points. Define the equilibrium and classify its types by quoting example from everyday life. State the two conditions for the equilibrium of a body. Solve the problems on simple balance system when bodies are supported by one pivot only. Describe the states of equilibriums and classify them with common example. Explain effect of position of the center of mass on the stability of simple objects. So first topic, like and unlike parallel forces. We often come across objects on which many forces are acting. In many cases, we find all or some of the forces acting on a body in the same direction. For example, many people push a bus to start it. Why all of them push it in the same direction? All these forces are applied in the same direction, so these are all parallel to each other. Such forces which are parallel to each other are called parallel forces. As shown in the figure, a bag with the apple in it. The weight of the bag is due to the weight of all apple in it. Since the weight of every apple in the bag is the force of gravity acting on it vertically downward. Therefore, weight of apples are the parallel forces. All these forces are acting in the same direction. Such forces are called like parallel forces. Definition: like parallel forces are the forces that are parallel to each other and have the same directions. In figure number 2, an apple is suspended by a string. The string is stretched due to weight of apple. The force acting on it are weight of the apple acting vertically downward and tension in the strings pulling it vertically upward. The two forces are parallel but opposite to each other. These forces are called unlike parallel forces. Force F1 and F2 are also unlike parallel forces because they are parallel and opposite to each other. And according to the definition, Unlike parallel forces are the forces that are parallel but have direction opposite to each other. And the next topic of our lesson, addition of forces. So in these topics we will discuss how to add the forces and the vector forces. Forces is a vector quantity. You already have read in the previous and chapter number 2 about a vector. It has both magnitude and directions. Therefore, forces are not added by ordinary arithmetically rule. When forces are added, we get a result forces. As shown in the figure, a resultant forces is a single force that has the same effect as the combined effect of all the forces to be added. One of the method for the addition of the force graphically method, and the method force we can add by head to tail rule of vector addition. In the figure, graphically method of vector addition. First select the suitable scale, then draw the vector of all forces according to the scale, such as vector A and B as shown in the figure. Take any one of the vector as a first vector, vector A, that is represented by blue arrow. Then draw next vector B such that its tail combine with the head of the first vector A as shown in the figure. Similarly, draw the next vector for the third forces, if any, with its tail coinciding with the head of previous vector and so on. Now draw a vector such that its tail is at the tail of vector A, the first vector. The red line show in the figure resultant vector, while its head is at the head of vector B. The last vector as shown in the figure, vector A plus B. A plus B show the resultant vector. Resultant forces completely in the magnitude and direction.